Welcome, everyone, to this installment of the Semantic Exchange. This is Enterprise Knowledge's new webinar series, which gives people an opportunity to interact directly with the thought leaders from Enterprise Knowledge. Specifically, we're hearing from some of our semantic design experts. We're taking a look and deep diving into pieces of thought leadership, blogs, articles that they've published recently, and getting an opportunity to ask questions around those. So this is an interactive format. You're welcome to use the Q&A functionality within the Zoom here to insert your questions, and we'll get into those. A little bit about Enterprise Knowledge. We're a knowledge management consultancy based in the DC area, and we do work across the spectrum of knowledge management. Taxonomy and ontology is a lot of what you hear about, as well as knowledge graph in this series. We also do quite a bit of work in the enterprise AI space, artificial intelligence space, as well as knowledge management, development, and so forth. So we're really excited to have this opportunity to share more with you today. A little bit about how things will go today. We'll hear from James Egan, who is our ontology consultant in the semantic design and modeling practice at Enterprise Knowledge. He's going to give us a brief overview of some work that he did with a Humanitarian Foundation, working on a SemanticRAG proof of concept. So that's a pretty cool story we'll get to hear more about from James. He'll give a brief overview of the piece of thought leadership that he published, which is a case study, and then we'll open it up to questions. So with that, I will make one quick announcement, and then we'll get into the meat of it today. So if we can go to the following slide, wanted to share with this group another really fun thing that Enterprise Knowledge is up to right now. So later in September, we are hosting our second annual Semantic Layer Symposium. We kicked this off last year to huge success. It's an opportunity to connect with other experts in the field and deep dive into the semantic layer. So this is something that we wanted to put on your radar if it wasn't already. We will be in Copenhagen in Denmark October 1st with a workshop preceding this on September 30th, which is an interactive all-day workshop exploring how to build a semantic layer from end to end. And as a thanks to you for joining us today, we're offering a 30% discount, so you can follow this code and register, and we hope to see you there. So with that little bit of information, James, I would love to turn it over to you to give us an overview of your SemanticRAG POC case study. Then we'll go into questions. Thank you.
Awesome, great. Thanks, Sarah May. Let me just switch over.
Sure.
So here's the case study overview of this use case for its Humanitarian Foundation. And essentially what this was about was we were comparing a semantic RAG approach to a naive RAG approach and other graph RAG approaches that this foundation had taken when it came to trying to extract information from unstructured text, essentially documents describing the goals and progress and overall results of different investment packages that they were running. And the semantic RAG approach is essentially RAG, which stands for Retrieval Augmented Generation, using an LLM and different agents to go into a unstructured text and select different portions that are relevant to a query, and then bring them back into the response for the user and summarize that information. With the semantic RAG approach, what we were offering is using a RDF-based semantic web standard-based ontology and knowledge graph, in addition to the unstructured documents, to be able to find exactly the relevant portions in those documents that address the queries that different users might have. So the overview of our approach here was we began with defining that system functionality. And essentially, we wanted different users, like, for example, an investment manager, to be able to ask a question in their own natural language, and then to receive a generated response that could reliably contextualize the information that they're looking for in those investment documents, as well as provide some way to be able to track the sources and see the work that was done, to check the work and make sure that the answer is as reliable as possible and sourced in the document itself. So to do that, we built a chatbot model, which could leverage a knowledge graph that combines structured data about the documents and investments themselves, as well as the types of concepts within those documents and what kind of information might be in some of the standard queries that, for example, an investment manager would use to evaluate the progress and overall results of an investment. And the chatbot then could predict essentially what answers were being looked for on the basis of keywords in the question that the user is asking. And essentially what it does is that it converted that into Sparkle queries to query the knowledge graph that we built based on our ontology, and then find exactly which document is going to address the question in the best way. Once we put all this together, we put it in a containerized web application stack so that it could be loaded and be moved around and portable in different environments. We built it in our environment as well as in the foundations and allowed them to use it and test it there. And some of the early feedback we got was about the ability that we had to both query a knowledge graph and the unstructured data, and then kind of seamlessly stitch this together in a way that you could track. So we had a little side panel along the side that would show the step-by-step process of converting that answer into different Sparkle queries, and then identifying which document to look in for the question, and then the relevant portions of those document, and then this actual summary and response that would be returned in the chat. Beyond that, then we provided a roadmap for further development of how we could expand the ontology, how we could expand this application to cover more in-depth and finer-grained queries, how we could expand the knowledge graph to add more structured data to support the context in looking through these documents, as well as changing content models for the documents themselves and understanding different relevant sections particular to a document that would address different types of topics. All of this can perform better than other types of retrieval augmented generation because they're following this structured path provided by the ontology and semantic web standards. Overall, I really enjoyed this project. It was kind of a fun mix of a lot of different applications, and I really think it's interesting the ability now with large language models to combine older technology from semantic web standards like ontology and RDF-based graphs with now more enhanced ability to, instead of having to write complicated queries and languages like Sparkle, now users can just type in a natural language question, and there's enough context and information provided that the chatbot can then return that in a natural language response that accurately summarizes an answer to their question. And that is really kind of the EK difference here, is that we were mapping that data through our investment ontology, putting it through our knowledge graph, and connecting it through our SemanticRAG agentic workflow. I think I'll pause here and then we can go into any questions about the application or the process.
Thanks, James. That was a great overview. Something that sticks out, I think, is you're talking about working with both structured and unstructured information. Can you talk a little bit about some of the challenges inherent to that? I think we're traditionally we've seen that organizations treat structured and unstructured information differently. You know, they're managed by different parts of the organization. There's not a lot of interaction there. But we're seeing more and more, and Enterprise Knowledge is writing about this and working in this space in terms of knowledge assets. We're seeing more and more the need to kind of treat, you know, different types of data and information in more of a coherent sort of way, more of a holistic way. So you got to do a little bit of that in this engagement. What were some of the challenges that came up? What would you say to look out for others doing similar work?
So we had only a little bit of structured data where we were able to understand at least what investment a particular document was talking about. And these investment documents, though, were in different shapes, where some of them were all in one big document. So you'd have an entire document summarizing the entire investment from its proposal stage through its progress, through its final results. And others were separated out into different types for those different stages. So the challenge was that we had an ability to understand that the document was about a particular investment. We might have dates associated with that. But in terms of the actual content in the document and the performance results or what the goal of the investment was, this was something that was very difficult to be able to instantiate in our knowledge graph in a structured way and convert it to structured data. So the solution that we came up to was that we defined different concepts that these documents were going to be describing, for example, an investment goal or investment progress. And we were able to write OWL axioms that linked it to back to particular documents. So for example, a proposal document would be about the investment goals. So by identifying them, like, well, this document is talking about, this question's about an investment goal. So let's look at the investment proposal and look for keywords based on goal, as well as alt labels that we had, like objective and things like that, with the definitions that we provided in the ontology. That definitely is a challenge where you have essentially large blocks of text that aren't standardized or structured, that you want to be able to link in a knowledge graph, but we weren't able to. So the real difference here was the LLM tool.
Nice. Yeah, that makes sense. And you talked a little bit about you know, referencing the ontology and its role within this solution. Could you talk to us a little bit about your ontology design process? What were some of the methods used to develop that ontology that is sort of underneath all of this?
So we were essentially modeling, you know, two different things together. We were modeling investments themselves as a domain and what an investment is, and different relationships to things like budgets and goals. And we were also modeling documents that were about those particular investments. So part of our initial discovery phase was to go through and develop competency questions where we could identify if the solution is answering this question, then we've successfully structured it, and the whole project is moving forward. From those competency questions, you can then extract, these are some of the key entities that are going to be relevant for the ontology, for example, investment and goal and progress and different concepts like that. Part of the key structure of the ontology was that aboutness relationship, where a document and the information specifically in that document is about something else out there in the world, like an investment performance, a score. So we were able to then kind of like build up from there in that basic structure.
That's fascinating. Great. Let's see, another question that we have here is around validating the responses from the solution. So, you know, this is important to know that what's coming out is something that can be used and relied on. How did you test the solution and validate that it was returning accurate responses?
Part of this was difficult because the challenge was the foundation was having trouble doing this. There's so much information to pour through. So to do this, we selected just one or two sets of investments and documents. And we went through and understood and read, well, this is the section that's talking about goals, for example, or performance or budget changes. And went through and had sample questions that we wanted to make sure the chatbot was going through and at least touching on and getting from that section, and then would compare with the answer. Another aspect of this too was writing different Sparkle queries, making sure that the Sparkle queries that could be generated in the agentic workflow were going to match up correctly and make sure that we're querying for things like investment and document together to be able to pull the right document.
Excellent. Another question we're getting here is around the data processing aspect of this. What were some of the steps needed for data processing, and what does the process of semantic extraction look like?
I think you touched on this a bit, but essentially we ingested a lot of metadata that they had in structured tabular formats into our knowledge graph. And a lot of this data was about an investment, the document, the people who worked on it, the manager, the score, the dates, and set all of that up in a structured way in our knowledge graph. Once that was built, we also had a way to link back to the actual documents themselves that were held mostly stored in different formats and different ways, but we had kind of a curated set. From there, then the LLM is the agentic workflow is basically able to go through, get as much context from the user's question, compare it to the knowledge graph and the data that is ingested in there, and then use that to pull out information from the most relevant documents to that question.
Great, thanks, James. I think we have time for one more question here. So if people were interested in taking the semantic RAG approach that you've described and bringing it to their own use case within their own domain, how would a similar architecture be used for similar use cases? Can you talk a little bit about the value of this semantic architecture in particular?
Yeah, I think essentially what this is doing is combining new tools like generative AI and large language models with older tools like RDF-based knowledge graphs and the capabilities for inferencing and reasoning that are provided by OWL-based ontologies. So I would start there of understanding the domain that you're working with and making sure that your model can accurately address possible user questions, as well as be expandable and not run into contradictions as you understand you have more use cases and more things to ask. And from there, developing an agentic workflow and building out different ways so that when a user asks a question, that can be translated back into all of the context that you have in that RDF-based graph.
Yeah, that's great. And I think we're also hearing, as we're working with clients, that one of the reasons to, add the ontology component to this architecture is, if they're in a highly regulated space or really reliant upon that accuracy that you've talked about, that is a great way to ensure or enable that to happen within solutions, is having the traceability and that definition that comes through those models.
Yeah, absolutely. I think like the ontology itself is something that you can set so many rules for to validate and make sure that your data is accurately mapped to the terms in your ontology. And instead of other approaches where you're just sort of doing large scale comparative analysis and predictive analysis. And this one is built on a very structured, logical format where it's using the ontology web language OWL to be able to make logical kind of arguments, essentially, that if this, then that.
Mhm.
So it really increases the reliability and context that you can add to tools like LLMs.
Mhm. Great. And was taxonomy part of the solution?
In a way, yeah, we used it a little bit differently, but we instantiated some of those concepts like goal and progress as essentially a taxonomy of different types of topics that the documents could be found in those documents. But then we pulled that back into the ontology and the knowledge graph, so it was all kind of one graph, and linked it together with different all axioms and object properties.
Great. Excellent. Well, that's what we have time for today. James, thank you so much for being our guest at the Semantic Exchange today. It was really great to hear more about this work that you've done. This is the final installment in our first series of the Semantic Exchange. You'll be hearing more from us soon, and we look forward to further interacting with you. Thanks, everyone, for joining us today.
Thanks, everyone.
Bye-bye.